Simple science. What are magnets and springs? A magnet exerts a force on other magnets and on metal objects made of magnetic materials. What happens when a magnet is placed near a paperclip made of steel? The paperclip is pulled towards the magnet by an invisible force of attraction. What happens when you place the magnet near a piece of aluminium foil? Nothing. Only some metals, including iron, nickel, cobalt, and iron alloys such as steel, are magnetic. Metals such as gold, copper, and aluminium, and materials such as paper, fabric, plastic, and wood are not attracted to magnets. A magnet has two ends, or poles, a north pole and a south pole. Opposite poles of two magnets attract, or pull towards each other, and like poles repel, or push each other apart. The difference between a magnet and magnetic material is that a magnet will always attract magnetic material, but a magnet will attract or repel another magnet, depending on whether opposite or like poles of the magnet are facing each other. The force of magnetism can work through a variety of non-magnetic materials, such as paper, fabric, aluminium foil, and plastic. That is why you can use fridge magnets to attach notes to a fridge. The fridge is made of steel, and so the magnet sticks to it, even though there is a layer of paper between the magnet and the fridge. Another use of magnets is in recycling, where powerful magnets are used to separate iron and steel from non-magnetic rubbish. Springs also exert forces on objects when they are compressed or stretched. When a spring is stretched in one direction, it exerts a force or pull in the opposite direction as the spring tries to return to its original position. The further the spring is stretched, the greater the pulling force that is exerted in the opposite direction. Also, when a spring is compressed in one direction, it exerts a force or push in the opposite direction. These properties of springs make them useful in everyday objects, from mattresses to pogo sticks.